Software systems are complex beasts. There are a lot of moving parts and as a result, a lot of things that can go wrong. And let me assure you, things will go wrong. This is one of the axioms of the software world. The real question here is, what happens when something goes wrong? Sometimes the answer for that is what makes the difference between a well-architected, easy-to-maintain system and a system that lacks a big picture view. A good architecture will always include logging and monitoring engines. These are the cornerstone of maintainable systems and make finding and fixing problems much simpler and faster. The goal here is that when there is a problem, a quick glance at the system's logs will direct us immediately to the source of the problem and will provide us with as much as possible information regarding the problem. In addition, monitoring will allow us to view the current status of the system and notice problematic trends such as high memory consumption or above average exceptions count. Now, we already talked a bit about logging and monitoring in the software components architecture section, and I want to add to that two topics that are very important in a full-blown system. The first is central logging service. Since most systems comprised of more than one service, which are developed by separate teams, often each team uses its own logging mechanism. What happens is that every service has its own log format, its own log data, and its own log location. One service might keep its log in the file system as a fixed format file, the other will store log records in a relational database, while the third service will store JSON documents in a NoSQL database. Each one is a legitimate approach, but it's extremely difficult to understand what the hell is going on with the system when the developers should look at many sources with many formats in order to read the logs. The preferred approach is to create a central logging service that all the other services write to it. This central service will store the logs in a central repository, preferably a database to improve querying and analytics, thus creating a single point of viewing for the logs data. There are various methods this service can get the logs. It can expose an API for the other services to use, or it can watch specific folders for log files and then collect them. Tools like Logstash do just that. It watches a folder, and when a file is added or modified, it collects it and stores it in a data store. It doesn't really matter which approach you will take. The bottom line must be the same. The logs of the entire system must be accessible from a central point and must be present as a single format. The second topic is correlation ID. When our system has many services, we will have a lot of business flows that include more than one service. We saw some examples previously during this course. For example, an investment recommendation service that calls the stock quote service. Here we have two services participating in a single flow. One of the challenges in such a flow is to be able to understand which log record belongs to which flow. For example, say user 1 asks for a recommendation. The recommendation service calls the stock service for data, and then an error occurs in the stock service. Both the services implement logging, so we have a good documentation of what exactly happened. In this case, we have a log written by the recommendation service indicates what the user asked for, and a log in the stock service documenting the error. So far, so good. But what will happen if, in parallel with user 1 request, we have another request initialized by user 2? Let's say in this case, no error was thrown in the stock service. We now have 4 log records, 2 of the recommendation services and 2 of the stocks. One of them documents an error. How can we find out which record belongs to which flow? It's not clear that the error belongs to user 1's request, since there is nothing in the data that attributes the error to a specific request of the recommendation service. The solution to this problem is correlation ID. Correlation ID is an identifier that is assigned to a flow at the beginning of it and is passed from service to service. It is included in every log record and enables us to track the flow from start to end. The correlation ID itself can be whatever identifier you will want to use. GUID is a popular choice. The only important thing is to make sure it is created at the beginning of the flow and is included in every log record. Using correlation ID, we can easily track a complete flow and understand what exactly happened in the flow and, more important, why. So to summarize, use central logging and correlation ID to make the system easy to maintain, especially when the system has many services that are used by different business flows.